So if you came into this room, you're here for the 5 stages of cloud native. How many people are cloud natives now? And maybe you've gone through some of these phases. Maybe some of them will be familiar to you. This is a talk, I guess, about war stories and some things that I've learned and seen along the ways. I've got scars, but I'm not really going to show them to you. We're just going to talk about it, though. So that's what we're here to talk about. Right off the bat, you can find me on Twitter, so this is a good way to start trolling, like troll early, troll often. You know how to reach me. You can also email me if you want to. That's my work email address. There is a non-zero chance I would read that email, so give it a go. And I write some things online. You can also find other ways to reach me at caseywest.com. If Twitter's too new of a technology for you and you're not really hip to that new stuff, and maybe email just feels too old, then somewhere in the middle might be Microsoft LinkedIn or something like that. You could join my professional network. I'll endorse you for awesomeness or whatever. It's professional. Awesomeness, greetings maybe if you say hello. All right, and if you do use Twitter, maybe you're not super hip to hashtags, but I have some starter hashtags for you. You can use any or all of them. There's the S1P, hashtag cloud native, hashtag real talk, and hashtag therapy, because it's kind of where we're going today. Thanks Pivotal. They let me fly around the world, meet people like you, have conversations. It's going to be great. So the 5 stages of cloud native, I'll just give you the agenda. Again, if you've already gone through a migration towards something like the cloud, or if you're in the middle of it now, some of these might be familiar to you. Denial, anger, bargaining, depression, and then finally, the ever-elusive acceptance. I'd like to talk through some of the scenarios that we face when we go through some of these phases. So now that you know what the 5 stages are, is any of this familiar to you? If you raise your hand, I won't assume that you're in therapy, but I do some therapy. It's all good. We can be honest here. Okay. So let's have a seat on the couch. You can just get comfortable, however you want to get comfortable. It's fine. Relax. I have a coffee. I don't know if you have a coffee, but I would recommend it. So there are some basic ground rules. We won't talk about any weird stuff. No family issues. No back history or anything like that. But we will talk about delivery pipelines and your architecture and your automation. These are things that are definitely within bounds when we're discussing the 5 stages of cloud native. Is this cool with everybody? Nobody's left the room yet? Feeling good with this? Okay. So we'll start the clock. We have about 30 minutes. Not quite an hour, but when is it ever quite an hour, right? Okay, so this is something that I hear a lot. Deploying my apps to the cloud is painful. And why is it painful? And this is often from people who are first trying to go to the cloud when they haven't done it before, or when their current model is to deploy to something that does not resemble a cloud-like thing. Obviously, we all know exactly what the cloud is, like super easy definition, everyone? Someone else's computer, right? Right, a computer that someone else manages. We have a lot of fun in our group talking about what no-ops and serverless means. You heard a little bit of that from Bridget this morning. So in any case, it can be painful, and so we can talk about some of the reasons why, and I think we should start at the beginning of this journey with denial. Containers are just like tiny virtual machines. So if we're going to go to the cloud, obviously we should use containers. It's a small and unheard of technology. Anyone heard of containers here? Nobody, wow. Yeah, that's usually what I get. I get nobody. Let's try this a different way. I'll ask the same exact question, but I'll use a different word. Who has heard of Docker? Okay, more people. So, oftentimes the first experience that we have when we go to containers, or we try and go to the cloud, is to try and cram an application into a container. And the first thing that we think of is this is a lightweight virtual machine, so we'll just sort of treat it the same way. Our operations and our IT team, they're like, well, I've been building golden images for years. I'm really good at that, so I'm just going to build golden containers, and it's going to be great. And the truth of the matter is that doesn't end up working out very well. This is usually the first thing that we do because we don't really want to accept that there is a very different way to package and distribute applications on the cloud than there was whenever we were doing things like golden images and one virtual machine or one server per application instance. So this is usually one of the first things that I hear. And we have to say, well, no, actually, we're trying to package applications as a much smaller, lighter weight, smaller footprint thing, and then distribute those. And we have to do this a little bit differently. Another thing that I hear is we don't need to automate continuous delivery. In fact, I've had people talk to me about this. By the way, who's doing automated delivery to production right now? Like a one-click something or another? Yeah? OK, then how many people here have their 100-point checklist that some person gets shackled to their desk to perform in order to get your applications out the door once every 6 months, right? Yeah, so when I talk to people who are in that position, first of all, usually it's over beer. I'm so sorry I don't have a beer for you. But when I do, I have to relay one of my own stories, which is trying to get an application into production in an automated way. And my release engineering and quality assurance teams were under a lot of fire for our deployments because they were not very successful. They kept breaking. They kept breaking every single time we would deploy, and in very different ways. And we looked at the problem, and we saw, well, we're doing a very manual process. We really did actually have a 100-point checklist, and while the shackles were not real, they felt real. And we had people who really just did have to be stuck at their desks for 8 hours trying to deploy. And the problem was it broke differently every single time. And I said, well, what if we automate this process? And my release engineering manager said, until development can produce software that gets reliably built and delivered manually, we should not spend any time automating. And I'm like, well, what if it broke the same way every time? Like, then we could fix it once. We could check it into some revision control, and we'd be OK. So this is usually the second piece of denial, is we don't want to invest in a one-click deployment when deployment already sucks, right? Oh, I might use swears. Yeah, we'll see how it goes. OK. I just realized I didn't put that caveat in there. All right, we already automate infrastructure with Puppet. So we're good. Like, we got everything down. Is anyone rocking the configuration management? Right? It has its purpose, right? Absolutely. Now, I do come from a Cloud Foundry camp, so I'm like, what if the automation was already completed and we didn't have to mess with it anymore? And that works for many applications, but not all. But that's usually the problem, is that we've got this one-size-fits-all solution mindset here, where we're like, you know, we've got a solution, and we have to bang on it all the time. Every time we want to change the shape or the size of our architecture, change the way that it looks, we have to do a lot of manual work on our automation. But that's how we automate, right? That's what I hear a lot. So I would say, if your automation requires a huge amount of manual labor, how automated is it really, right? And this is one of the next things that we hear, is that this is as far as we need to go, right? We've raised the bar up to infrastructure resources can be automated, and that's good enough for us. And I think that the issue with this is it doesn't solve enough of the problem, right? There are still so many more problems you have to solve, and you end up toiling away at doing this all the time. OK, so we get to anger. Anybody here at anger? All right, you don't have to raise your hand. So, works on my machine. Anybody said this? Oh, so many times, right? Now, I come from an application engineering background, so I'm the sort of programmer that builds things that people in suits in boardrooms call business value. And so what that means is I work with a lot of people who are more on the operations side of the house, who are busy trying to keep the stuff that I threw on their heads alive and not on fire, right? And I've been in so many meetings where obviously I have an excellent developer environment and my application works on my machine and everything is going great. And then we get into production and everything is on fire. So real story, for real, I have been in a meeting where I have handed my laptop to an operations person that said, please install my laptop in the rack in production. Because I can produce an environment that works, and apparently you can't. And the truth is, yeah. I don't know what's wrong with you, but these are pretty powerful machines. We can probably cram 4 of them in one U space. You know, we can make this work. So The issue with that, of course, is we want repeatable and reliable builds. And the fact that I could get it to work on my machine and we couldn't get it to work in production, or often vice versa. It's amazing how often a feature works on your developer machine and how infrequently a bug it fails to show itself on a developer machine, right? Isn't that interesting? So as a developer, I'm like, my feature works, it's perfect, but you can't make that run in production. And then when it comes time to debug some gnarly thing that's going on in production, the operations people are like, dude, fix it. I'm like, I don't know, I can't make this bug work. I don't actually think it's real, it doesn't exist. That's actually interesting. And you know, the reason that this is maddening is because, and I think that this is a fundamental problem that we really have to accept, is that this is a people problem, right? When this happens, this is a cultural issue. And I know that we spend a lot of time talking about software and digging into code, and that's important. But the way that we deliver software, the way that we work together is just as important. We heard a bunch of that in the keynotes as well. And when it comes to something like it works on my machine, this is a clear breakdown in communication, well before the fact that our operations people couldn't seem to provide a reasonable environment, right? So when it blows up in production, we as developers say, and I bet that I bet there's at least one other person who's done this. We often say, well, you know what, just give me a little more access to production. I'll get in there. You know, I can make it work on my machine, so I'll get in there and I'll just do some live coding, some live debugging. Maybe I'll, I don't know, do a hot fix, you know? We all love our hot fixes. And, you know, because I can figure this out, and it's fine. And then, of course, the operations people are like, all right, so listen, son. You have spent the last 7 releases producing things that do not work. And every time I see them, they set my stuff on fire. And you're asking me to give you more access? Are you out of your damn mind? And you know, that's a reasonable response, because actually, as developers, we have done that, right? We have done that. Now, this is where a lot of the technologies and a lot of the tools that we're able to use when we go to the cloud start to enable better communication structures. It's almost a tool-enforced environment to build trust, because there are certain restrictions that we can adhere to. If we're going to a container and we have to package an immutable artifact, if we actually really have to make one thing that we can distribute to multiple environments and make it work, that's a constraint on us as a developer that actually gives us the opportunity to maybe build something that's reliable that doesn't just work on our developer machines. And that constraint allows operations people to know, hey, the system's actually going to enforce whether this works or not, and maybe I don't have to be such an asshole about the fact that it never works in production, because the system will actually do that. So that's good. So we can almost get around this. We can start to see our way through this journey. Here's another one. Devs just YOLOing shit out into production. Let's say that we've gotten past the idea that manually managing our automation isn't really automated, and we use something like Cloud Foundry. Then we're like, well, this is developer enablement. We're enabling our developers to push to production, and everything's going to be fine. And in fact, the development teams are going to say, I want all this power because I've been hamstrung by my operations people, and I'll just take on all the responsibility. I know when to go to production. I'm going to push it out, and everything's going to be great, right? And of course, this doesn't actually work in practice either. It's also maddening. In fact, how many people here work in an industry where you've got regulations, compliance, stuff like that? Right. So your IT professionals, your operations people, especially even at the executive level, have literal legal obligations to not fuck up in that environment. And as a developer, like, they'll go to jail. Ask, you know, people from Sony or Target what the ramifications are when things don't work quite well. And while that wasn't because of containers or the cloud or anything, the situation is very real for them. And for developers to just say, you know what, fuck all that, I don't even care. We're just gonna push it to production because we know it's best. Get out of my way. It doesn't really end up working. And it's incredibly maddening because there's a lack of acknowledgement about the roles and responsibilities that we each have, that we all have, in delivering value to our customers. But we'll get to the next phase. Bargaining. We crammed this monolith in a container and we called it a microservice. Yep. Yeah, we heard a little bit about that this morning as well, didn't we? So, anyone done this? We like to call it lift and shift, is one of the things people sometimes call it. So this is an awesome plan where in order to attempt avoiding the cost of refactoring or replatforming your application so it will behave well in the cloud, you cut all the corners and you use all the features that are available to you to make an old shitty system that doesn't work well in the cloud just at least appear to behave in the cloud, right? So this is I often see things like this when it comes to container adoption, right? So with container adoption, you look at a great interface to containers like the Docker format and the Docker interface, and you're like, I can do all these things. I'll volume mount everything from every host everywhere. And then you're like, wait, that doesn't actually scale. And so we see this a lot. Or we try to cram an application that takes 16 gigs or 20 gigs of memory into a container, and then we're like, we'll just horizontally scale it. And you're like, how are you going to do that? That doesn't really work either. So this is another situation where we need to respect the fact that things don't always work the same way in every environment. If you deploy to big, huge computers and data centers right now, and then you try to go to a virtualized, elastic environment like any IaaS provider or something like Cloud Foundry on an IaaS, your application has to adhere to different constraints. There are different architectural patterns at play. And you have to really think hard about putting in the sweat equity to do it. And the problem here, as I said a little bit earlier, is that we're trying to avoid the cost of moving our application into the cloud by just like cramming our application into a package and hoping it runs well in the cloud. And the thing is that only kicks that cost down the road, and you still have to pay it at some point. And this is one of these things that I often see a lot of vendors of cloud solutions talk to this point. And what they say, and I'm not here to like be a vendor shill or anything, but I hear a lot of vendors say, well, we can help you get your current application with very minimal work into the cloud, into our cloud-like environment, and everything's going to be fine. And yeah, you'll get one or two instances running in the cloud, but then when you want to take advantage of the capabilities that you're supposed to get when you go to the cloud, elasticity, dynamic increase and decrease of load and capacity availability, things like that, it's nowhere to be found. You can't take advantage of those opportunities anymore. So they're like, yeah, we can get any application on the cloud, and then it's on the cloud. And I'm here to say, like, that's actually bullshit. And it takes real sweat equity. It takes actual work. There is still critical thinking involved in moving your application to the cloud. You have to plan for it. You have to make a plan. So don't let anyone tell you that they can get your application running in their system and then it's magically okay. There's no magic. We cool? I feel like we're in the sad part of the therapy session. All right, bimodal IT, another bargaining. I think Bridget spoke to this in her keynote. She said there's an awesome mode and a sad mode. Anyone practicing bimodal IT right now? Got a couple of folks? Cool. So I have a particular take on why I think that this is bargaining and it's not a real solution. I mean, the one that's sort of obvious that we can easily say is that there's a spectrum, and that every application in your portfolio probably deserves its own particular cadence, feedback loop, and iteration cycle, right? And there's no one-size-fits-all, and there's certainly no two-size-fits-all. But the big problem that I see with a bimodal IT strategy isn't that you relegate a team to sad mode and then they're sad. It's that they want sad mode, and they want the excuse to stay where they are because they fear replatforming or moving their application into the cloud because it's an unknown. They're not sure how to do it, maybe. They're not sure how the application will perform, whatever the scenario is. But I've seen too many people use it as an excuse that we don't actually have to change anything. And if you're working on a particular application that is important to the livelihood of your business, that you have to modify frequently, then that's something that should be in the fastest delivery mechanism that you have available to you, right? And if you have a team managing software like that who is unwilling to change, bimodal IT is often the perfect excuse to just hide out and ride it out rather than do the right thing in order to make the software more successful. So I also see this as a bit of bargaining. Okay, let's see. So what if we create microservices that all talk to the same data source? This is the first misstep down a microservices strategy that I see most organizations go through. And I will admit that I did it myself. was working for a company that had a very large data set in a database and a very large Perl application that was running their entire business. I'm actually cool with Perl. I'm not here to bash Perl. Perl's rad. If anybody wants to throw some Perl into production on Cloud Foundry, come talk to me. We can do that. Yeah, I see no hands raised. I don't feel judged at all. I thought this was a safe place. So we had this organization, and the issue was that we had this very monolithic application. It was very hard to change, very hard to manage. So we started breaking it up. And we're like, well, we've got these discrete pieces of functionality. We have user management, we have group management. We happen to be a web security company, so we've got things like vulnerability detection over here and a bunch of other fun stuff. And so we can start decomposing this. But we looked at our database, and there were some folks in our team who were very much disinterested in starting to tease that apart as well. That our data model, incidentally, was informing the bad architectural practices that we were using, and it was also keeping us hamstrung from actually pulling things apart and gaining a lot of the benefits you get from microservices architecture. So one of the huge benefits that you get from microservices is that you can have single responsibility and data ownership with a clearly defined programmable interface between services. And we decided to completely destroy that model and instead make the common layer continue to be SQL to our backend data store. And the problem with this is that you don't really have microservices. So we heard about, I only heard about this recently. This morning, I think Phil Webb said there's monolithic architectures, and then there was mono-horrific architectures. This is like not microservices, but sort of Hydra services. Right? You've got this big ball of stuff with many heads that all have their own idea about what to do. And the problem here is that you end up with applications that are all accessing the same data, potentially manipulating that same data, had different ideas about what the business logic is around how to manipulate and handle that data. And that's a really bad time. So that's why this is bargaining. If you are going down this path where you've got this big pool of data and you're just trying to do business logic layer microservices, you're already going down a bad path. And I would encourage you to take a step back and really break apart the data and find the seams the whole way through the architecture in order to make microservices that are fully autonomous. Then we had, the problem that we had as a follow-on effect is that each of our teams were then still bound to the release cycles and the understandings and the knowledge around that information of all of the other teams. So we still ended up with tight coupling between our teams and between our services. So don't go down this path. I'm sure that any one of us who are talking about microservices in our organization have at least had this conversation about what we're going to do about data. And it's certainly a hard problem to tackle, but we have to go past it. Ooh, now that everyone's super happy, let's get to depression. I heard an audible sigh. I like it. OK. We made 200 microservices, and we forgot to set up Jenkins. Yeah. So you remember that 100-point deployment checklist? Well, we also replicated that 200 times, right? And that 100-point deployment checklist that was fraught with human error, that made deployment day the worst day of our lives, the scariest thing we do in our job, we've now decided to do that 200 times more, right? This does not work at all. One of the major tenets about a cloud-native approach to building software is automating the path to production. It is an absolute necessity. If you don't automate the path to production for new services you're building, then you make that problem where you have the worst day of your life on deploy day that much worse for every single service you deploy. One of the things that was I'm referencing back to the keynotes all the time. So in the keynotes, they mentioned that one of the first things that Pivotal Labs does is build a CI/CD pipeline. They automate the path to production as one of the first things in a new project. So if you are going down the path of delivering applications to the cloud or decomposing large applications into a series of services, each of those services, the first thing you do is automate your path to production. Then you don't have to worry about the 3 to 6 months of excuses at the end of when you're supposed to deploy that holds you back from actually meeting your milestone. How many of us have actually made it to our arbitrary deadline, But then we were hamstrung by the fact that we requested a rack full of servers at the beginning of the project, but actually we need 2 racks full of servers. And we never told anybody because we never figured that shit out because we didn't do any of it until the end of the project. Don't do that. Set up continuous delivery. And it doesn't have to be Jenkins. It can be anything else. But do it. Do it, do it, do it. OK, we have an automated build pipeline, but we only release twice a year. So we've implemented everything we need for continuous delivery, except get the business on board that this is the riskiest thing that they could do as opposed to releasing smaller changes more frequently, right? This is one of the most infuriating things that can happen to an engineering team when you've done everything within your power to try and get your feedback loop as tight as possible, and then it comes to actually deploying, and you get into a meeting, and who has the go, no-go meeting, right? Isn't that great? Like that no one's ever going to say no-go, right? Too many people have their job on the line. They're going to find a way to cram that shit into production. No one's ever going to say no-go. But isn't that a pain in the neck meeting? That meeting should never happen. And ultimately, like when the one or two times when it does happen that somebody says no go, like someone gets in that room and you say we're going to deploy, and they look up from their laptops because they were just sending a bunch of emails and not really paying attention. They get out their lighter, set their hair on fire, and they're like, we can't deploy to production. This is a disaster, right? And it has to be this big event. It has to be this big painful thing. And it just sucks. It sucks because we want that fast feedback. We want to know if we're building the right thing or not. Nothing more expensive than building the wrong thing. But there's no way to know if we're on the right track if we don't get feedback, right? So we have to get that feedback faster. Oh, whew, we're at acceptance. And good timing for it, too. OK. Good job, everyone. All software sucks. It's true. It's true. Everything has problems. Everything has problems. But we have to respect the CAP theorem, right? If we're going to the cloud, we are working with distributed systems. Even if we're building a monolithic application, everything that application depends on when it runs in the cloud is connected over the network. And now you have network effects. And now you have whole new different types of failure than traditional 3-tier applications, right? New things to worry about. So the CAP theorem is something that must be respected. You can only pick 2. But pick wisely and make a real decision, right? Don't just let it happen to you. We have to respect Conway's law. We heard about this earlier today as well. That it is not really possible to build services that will communicate well with one another if the teams who are building those services can't talk to each other either, right? There is a cultural component. This goes all the way back to studies about socio-technical systems, which were done around the end of World War II. Discussing, there were some studies done about coal mines and their efficiency. More efficient coal mines had great tools, but even more importantly, the quality of life of the people working in the coal mines contributed significantly to whether or not that coal mine was efficient. Now, I know that we don't want to think of our jobs as working in a coal mine necessarily, but literally the quality of your life will manifests itself in whether or not you can build effective software on the cloud or not. I'll also say that small batch sizes work for replatforming too. Maybe it does make sense from an iterative approach to cram your application into a container, but then you can start to break it apart. Then you can start to refactor. Then you can start to provide more of those 12-factor principles into your application. And that's OK. Like get somewhere and then start iterating. We don't have to be a boil the ocean kind of conversation around this. Automate everything. It's really important to actually have things that are automated. If you can use tools or software that already have the automation completed, great. If you can't, build on top of what you have and automate it. All right, we made it to the end of therapy. So what have we learned? We've learned that if we're going to be able to afford to operate our software, operate our business, provide solutions to our customers reasonably, we need a good architecture. I think microservices has proven to perform well in this scenario. We need a great culture. The how we work together is just as important and probably more important than the tools that we use. And the DevOps mindset gives that to us. Things like shared responsibility, collaboration, measuring, learning together. And finally, we need continuous delivery. We have to automate our path to production. And unlike most of the lists of 3 things that we make in software engineering, where we very casually say you only need to pick 2 of these things, we actually need all 3 of these to be successful. Because if you try and go to a microservices architecture, but you don't have a culture of collaboration and sharing, and you haven't automated your path to production, you will not see the benefits, and you will not feel truly successful. So we need all of these things in order to be successful. All right, so I'm Casey West on Twitter. We can be friends. We can be friends online. That's what the Twitter handle's about. We could also be friends in real life, and that's what the beer emoji's about. So we could drink those beers. Although those are actually emoji, and you can't drink emoji. I don't know why you thought that. So, but we can get a real beer. Anyway, thank you so much for your time. If you have questions, I think we can do it outside. Yeah, thank you.